Good day everyone, and welcome to where we are putting together solutions to those math and science problems that students are getting. In this video, we'll be looking at CSEC Mathematics and the topic of relations and functions. We will be specifically looking at the past paper questions from May 2009 until 2013 in paper 2. Feel free to like the video and add any comments down below so we can create other videos to help you in any areas that you are struggling with. Don't forget to look at the description down below where we have outlined all the topics of the entire CSEC Maths syllabus for you to go through in that order for you to get a better understanding and therefore a better grade in this CSEC Math. Let's look at the 10 major topics in CSEC Mathematics, and in this video we'll be looking at topic number 7, relations, functions and graphs. This topic is tested for 8 questions out of the 60 in paper 1, the multiple choice, and in paper 2 for 20 marks. This comes in both section 1 and section 2. In this video, we'll be looking at only the section 1 questions of this topic. This topic comes every year and it came from 2009 until 2013. May 2009, number 5a. Given that f of x is equal to 2x minus 5 and g of x is equal to x squared minus 31. So there are different ways we can look at this. Let's draw a little flow chart so we can look at the functions. So let's look at f of x. If we input and we call that x and then we multiply by 2, that will give us 2x. And then we minus 5, that will give us our answer, our output. And we will call that output y, or in this case, a function of x, f of x. And similarly, we can do the same for g of x. Let's consider the input. Anytime we're looking at the input, we call that x. And then we square x. And whatever answer we get, we then minus 31. And that will be our output, g of x. We can't use the same letters because we want to differentiate between one function and another. Calculate the value of part 1, f of minus 2. So there are a couple of ways we can do this. One way, we can write it at the standard form where we write the formula, we substitute, and then we solve. So the formula f of x is equal to 2x minus 5. And what do we know? We know x. So let's substitute that. Wherever we have x in that line, let's write it in the next line and replace it by minus 2. So f of minus 2, meaning there's a function of minus 2, which means to say we're going to follow some particular rules. And that is equal to 2 times minus 2 minus 5. And 2 times minus 2, that will give us minus 4 minus 5, which is minus 9. We owe $4 and we owe $5, so that means we owe $9 in all. Another way we could have looked at this, because it's only worth 1 mark, then we're actually getting the 1 mark for the answer. So if we looked at our flowchart that we put above, if the input is minus 2, that's what we started with, then what do we do with it? We multiply by 2. So that will give us minus 4. And then we minus 5, minus 4 minus 5, and our output will be minus 9. And for part 2, find g f of 1. So this is a composition of functions, meaning 2 functions are happening there. The first function would be we're looking at the value 1 as our input, and we're operating what's closest to it. F is closest to it. So we're going to operate or use the rules of f on 1. That's the first step. So let's rewrite. F of x is equal to 2x minus 5. And we know x is 1, so we substitute. So we're going to get f of 1 is equal to 2 times 1 minus 5. And 2 times 1 is 2. 2 minus 5 is equal to minus 3. So that first part, f of 1 is minus 3. So instead of writing g f of 1, we can replace the f of 1 by minus 3. Let's write the formula again. G of x is equal to x squared minus 31, and substitute x for minus 3. So that will give us minus 3 squared minus 31. And let's recall minus 3 times minus 3. 3 3s are 9, a minus and a minus. They're the same sign, so it means it's positive. So g of minus 3 is plus 9 minus 31. And we don't need to write the plus in front of the 9, it's understood. So g of minus 3 is minus 22. As such, g f of 1 is equal to minus 22. We can look at it above. If we looked at the flow chart, if we put 1 in the pink boxes, then we multiply by 2, 2 ones are 2, the minus 5, 2 take away 5 is minus 3. Now that we got minus 3, we could put it into the yellow boxes now. That's the input for the yellow box. Minus 3 squared is 9, 9 minus 31 is minus 22. So it gives us the same answer. So it's a little way to double check. And for the part 3, f inverse of 3. What does that mean? It means that if we're looking at the pink boxes again, f inverse 3 means that the output is minus 3, and we want to go in the opposite direction of the arrows, going back to the left, to figure out what the x value would be at the beginning in order to give us minus 3. So we want to get the inverse function, means we want to go in the opposite direction. So there are a couple of ways to do this. Let's look at the first way. We can write f of x is equal to 2x minus 5. Most teachers write it this way. They replace the f of x as y. There are a couple of different ways to do it. So if your teacher did it differently, it's okay. At the end, we should end up with the same answer. So y is equal to 2x minus 5, and make x the subject of the formula. To make the x the subject of the formula, we need to get rid of everything on the right-hand side except x. So the first thing to remove is the minus 5. When we carry it across the equal sign, it will do the opposite of what it's doing. It's subtracting, so the inverse of that will be adding. So it will be y plus 5 is equal to 2x. And if we want x alone, then x is equal to y plus 5 divided by 2, because the 2 was multiplying on the right-hand side. We can now rewrite. So replace x by f inverse x and replace y by x. So f inverse x is equal to x plus 5 all over 2. Now that means if we started on the right-hand side in the pink box and we're going to the left, then we should be doing that, x plus 5 over 2. Let's see. So when we're starting at what we call the output there, that will now be our input because we're going backwards. Input means where we're starting. So if we start on the right-hand side, what's the next thing to do? The opposite of minus 5. So what's the opposite of that if we're going to the left? Instead of minusing 5, we're adding 5. So it'll be x plus 5. And when we get that answer, instead of multiplying by 2, what we will do? Divide by 2. So it'll be x plus 5 over 2, which is exactly what we just got. F inverse x is equal to x plus 5 over 2. And now we want to get f inverse 3. So if x was 3, then let's substitute. F inverse 3 is equal to 3 plus 5 over 2. 3 plus 5 is 8. 8 over 2, and that will give us 4. So let's see if we're correct. If we started with 4 as the input on the left-hand side box of the pink boxes, and we multiply by 2, 4 2s are 8, minus 5 is 3. Therefore, that will give us 3. Or if we started with 3 on the right-hand side and we work backwards, it will give us 8. As such, we're correct. May 2009, number 5b. Given that y is equal to x squared plus 2x minus 3, and we could draw a little flowchart again to help us if we're not seeing that, because there are some students who can see what we have in green easily, and some can't. They find it very difficult. So let's draw that little flow diagram so we could give them different views. So if we started with x, that's our input. And then what's the next step? We square x. So we get x squared. And after that, we add 2 times x. And then when we get that value, we minus 3 from it. That will give us our output, y. That's the formula that we're following to move from x to y. Part 1, copy and complete the table below. And if you look at the table, they've given us all the values of x from minus 4, minus 3, minus 2, straight up to plus 2. And they've given us all the y values except for 2 of them. So we need to solve those 2 values. When x is minus 3, what's the y value? And when x is 1, what's the y value? Y is equal to x squared plus 2x minus 3. And let x be minus 3. So we're substituting x as minus 3 there. So if we rewrite it, y is equal to minus 3 squared plus 2 times minus 3 minus 3. Minus 3 squared, as we did before, was 9. 3 3s are 9. Minus and a minus, same signs, will be a plus. So 9, and 2 times minus 3 is minus 6, minus 3. 9 plus minus 6, that is 3. 9 take away 6 is 3. 3 take away 3 is 0. As such, when x is minus 3, y is 0. And let's work for the next one. Y is equal to x squared plus 2x minus 3. Let x be 1. When x is 1, let's substitute. So we get y is equal to 1 squared plus 2 times 1 minus 3. That means y is equal to 1 squared is 1 plus 2 times 1 is 2 minus 3. So 1 plus 2 is 3. 3 minus 3 is 0. So for both cases, the y value is 0. Now we can check it back in the flowchart we have above, right? So for students who are getting problems to substitute and solve, they can draw the flowchart and work it out. Let's say the input in the first case was minus 3. We square it. That'll give us 9. 9, and we add in 2 times minus 3. That's minus 6. 9 minus 6 is 3. 3. And then the next box tells us minus 3. 3 take away 3 is 0. And if we did it for 1, 1 squared is 1. Plus 2 times 1 is 2. 1 plus 2 is 3. 3 minus 3 is 0. So both cases works out to be 0. So using a scale of 2 centimeters to represent 1 unit on the x-axis and 1 cm to represent 1 unit on the y-axis, draw the graph of y is equal to x squared plus 2x minus 3, the same graph that you just worked out, for the values minus 4 less than or equal to x less than or equal to 2. So what that means, we want to draw the graph from when x is minus 4, minus 3, minus 2, straight up till x is 2. And we have all those x and y values in the table already. So they give us a clear graph sheet, so we can draw our axes on it. Let's draw our x-axis and our y-axis. And the two axes intersect at the origin, or 0. Let's label according to the scale they gave above, 2 cm to represent 1 unit on the x-axis. So from 0, let's consider that each one of the darker lines is 1 cm. So that means we can label minus 4, minus 3, minus 2, so forth up to 2, where we're skipping out a line in between. Right? So that's 2 centimeters to represent 1 unit on the x-axis. Don't forget about x and y. And on the y-axis, the scale is a little different. It's 1 cm to represent 1 unit. So we can start with minus 4, minus 3, minus 2, straight up till 5. How do you know which values to plot? Let's look at the table. From the table, the least value of x is minus 4, and the greatest value is 2. So on our x-axis, we must have those covered. And on the y values, the largest value is 5, and the smallest value is minus 4. Now, we want to plot the points, and minus 4, 5, that's the first point. And then minus 3, 0 means at the y value is 0, means it's on the x-axis. Then minus 2, minus 3, minus 1, minus 4, 0, minus 3, 1, 0, and 2, 5. And now we draw a line through it, and we've completed the graph. So we finished the question. May 2010, number 5a. The functions f and g are defined as f of x is equal to 2x minus 5, the same function as what we had in the last question, and g of x is equal to x squared plus 3. So we can draw our flowcharts again, so students can get a better understanding of what's happening. So let's start with the pink ones to represent f of x. So the input is x, and if we're going 2x minus 5, it means we're multiplying by 2 first. We're taking x and we're multiplying by 2, and then we're minusing 5, and our answer will be our output. And we'll call that f of x, the function of x, meaning the rules that we apply to x in this particular case. And we have a next function now, g of x, so that means it's another set of rules that we apply specifically for this. So if the input is x, what do? We square x first, and then we add 3. And that will give us our output, g of x. Part 1. Calculate the value of a and b. First one, a, f of 4, meaning that if we substitute the x value as 4, what is our output? We do this 3-step formula, substitute, solve. So let's write the formula. F of x is equal to 2x minus 5. So f of 4, remember, wherever we have x, we're replacing by 4. So f of 4 is equal to 2 by 4 minus 5. 2 4s are 8. 8 minus 5. So f of 4 is equal to 3. And let's put it up in the pink box. Take a minute, put it back up there, and see if it works out. So if the input was 4, then we multiply by 2. 4 2s are 8. 8 minus 5 is 3. And it's the same answer. So we're correct. So for part B now, work out g f of 4. So it's a composition of functions, meaning that two things are happening. First, we operate on which function first. Let's look at the 4. If that's our input, what's the first thing next to the 4? F is it. So we have to work on the function f, or the rules that apply with the function f on 4. So f of 4 is equal to 3. We have already worked that out in part A. So we know that part. So instead of writing g f of 4, we know f of 4 is 3, so we could replace that part. Let's write the formula. G of x is equal to x squared plus 3. And let's substitute 3 squared plus 3. 3 3s are 9. 9 plus 3 is 12. G f of 4 is equal to 12. That means if we started with the input as 4 in the pink boxes and we went across, we got the output as 3, which we already did. And if we now take that output and put it into the yellow flow diagram, as that being our input, 3 being our input, that's what g of 3 is, and we squared, we got 9, 9 plus 3, we would get 12. For part 2, work out f inverse x. What does that mean? It means work out the rules if we're going backwards along the pink boxes. Meaning if on the right hand side we start with our input, what would happen if we're going to the left? Let's do it both ways. The first way, let's write it as teachers normally do it in school. There are different ways. F of x is equal to 2x minus 5, and all we want to do is make x the subject of the formula. We did this in the last question as well in May 2009, the same thing. Let's move the minus 5 across, so you get y plus 5 is equal to 2x. Remember it was minus, when you carry it across it will be plus. And now if we have 2x, we want to get x alone, we have to get rid of the 2. The 2 is multiplying on the right hand side. When I carry it across, it will divide. So y plus 5 all over 2 is equal to x. As such, we found the inverse function. The inverse function is whatever we're starting with, let's call that x. We're going to add 5 to it. When we get our answer, we're going to divide by 2. Let's look at the pink boxes. Does that say the same thing? If we're starting on the right hand side and we go to the left, instead of minusing 5, what we do the opposite, we add 5. So x plus 5. And when we get our answer, instead of multiplying by 2, we divide by 2. And that's exactly what we have. So we've solved part A of the question. May 2010, number 5b. The diagram below shows the graph of y is equal to x squared plus 2x minus 3 for the domain minus 4 is less than or equal to x, which is less than or equal to 2. Let's draw a flow diagram. If we start with the input as x, then we're squaring it, so we get x squared, and then we're adding 2 times x, and then we minus 3. And that will give us our output y. This is the exact question that came in the year before, in May 2009. So we have the graph, and we're operating from the domain minus 4 is less than or equal to x, which is less than or equal to 2. Meaning we're starting with minus 4 straight until 2. Use the graph above to determine the following 4 parts. Part 1, the scale used on the x-axis. So if you look at the x-axis, we could see 1, 2. There are 2 units or 2 centimeters to represent 1 unit on the x-axis. And of course, in the exam, you will have the paper in front of you. You could take your ruler and measure the distance from 0 to 1 or from 1 to 2. That means we're moving 1 unit. And how far is that distance? You write that, so 2 cm represents 1 unit on the x-axis. Part 2, find the value of y for which x is equal to minus 1.5. So if x is equal to minus 1.5, between minus 1 and minus 2, that middle line that's coming down there, the dark line, is minus 1.5. And if we go straight down and we read off the value, it's going to give us y is equal to minus 3.8. Don't forget the minus sign. Part 3, the values of x for which y is equal to 0. Notice they're saying values. That means that there are more than one value. So when y is equal to 0, that's another way of saying the x-axis. So what are the 2 values of x when the curve or the parabola intersects with the x-axis. X is equal to minus 3 on the left-hand side, and x is equal to 1 on the right-hand side. And the last part of the question, part 4, the range of values of y, giving your answer in the form a is less than or equal to y, which is less than or equal to b. What is the smallest value of y? Minus 4. So minus 4 is less than or equal to y, which is less than or equal to what's the largest value of y according to this graph? 5. May 2011, number 6a. The functions f and g are defined by f of x is equal to 6x plus 8. G of x is equal to x minus 2 all over 3. Let's draw some flowcharts so students can get a different view of it from what they're accustomed to. So let's look at f of x. Let's draw that in pink. So the input will be x. And what's the first thing to do with the x? Multiply by 6. And when we're finished multiplying by 6, that gives us 6x. What must we do? Add 8. So 6x plus 8 gives us our output. And we call our output, in this case, f of x. And for g of x, let's do the same thing. So g of x, our input is x. We have that in the yellow boxes. And then we minus 2. When we get our answer, x minus 2, what do? We divide that answer by 3. And that will be our output, g of x. So part 1, calculate the value of g of a half, which means that the input is a half. So let's write our formula, let's substitute and solve. Those normal 3 steps for any time there's a mathematical formula in any subject, that's the steps. Write the formula, substitute and solve. Quite simple. So the formula is g of x is equal to x minus 2 all over 3, that's given. And we want to find g of a half. So let's substitute x as a half. So g of a half is equal to half minus 2 all over 3. And we could use our calculators and work it out, or we could work it out in our head. A half minus 2 is minus 1.5 or minus 1.5. Minus 1.5 over 3 is minus a half. So g of a half is equal to minus a half. And if you put it into the yellow boxes and work it out, you'll see that it'll give us the same answer. For the second part of the question now, write an expression for g f of x in its simplest form. So we don't actually want to work out a value. If it was a value, then it would be gf and in brackets would have a number. Since it doesn't have a number, it just has the letter x in it. What they're asking us to do is come up with some sort of formula to represent that. How do we do it? Gf of x, when we're doing the numbers in the past questions, the first thing we look at is the x and what function is acting on it. The closest thing to x would be f. So we want to work out f of x, first of all. When we're working out f of x, let's work out f of x first, and we have that formula as given. F of x is equal to 6x plus 8. And now that we know that, what we're doing, instead of writing gf of x, we want to replace f of x by what we just worked out, 6x plus 8. So let's write our formula now. We know our formula generally for g of x. G of x is equal to x minus 2. And what are we finding? We're replacing x by 6x plus 8. So that is like if we did the pink boxes up on top, x, and we went straight across to the output, that was 6x plus 8. We're taking 6x plus 8 and making that our input in our yellow boxes. It now starts there. 6x plus 8, right? Let's write off, substitute that. G 6x of 8 is equal to 6x plus 8 minus 2 all over 3. Notice we replace the x by 6x plus 8. And we could simplify that. 8 minus 2 is 6, so we can rewrite g 6x plus 8 is equal to 6x plus 6 all over 3. And if we look at that, what can we do? We can factorize out the 6. So if we extract the 6, we're going to get 6 brackets x plus 1 all over 3. And is there anything else we can do? We can stop there? No, we can simplify even further, right? Because they want it in its simplest form. So 3 into 3, 1, 3 into 6, 2. So g 6x plus 8 is equal to 2 brackets x plus 1. We can leave it as is, or if you want, you can expand it. So g f of x is equal to 2 in brackets x plus 1. Or if you wanted, you could write 2x plus 2 by expanding the bracket. So that means if we started with the pink box as x, By the time we go straight across to the right, and then we take that value and put it into the yellow boxes and come straight down to the last box, the 8th box, then x would convert into 2 by x plus 1. And part 3, find the inverse function of f inverse x. And if you want to find the inverse function f inverse x, it means to say that we're starting on the pink boxes only. We're starting on the right-hand side, and we're going to go backwards. We've done this in the last 2 questions. So if f of x is equal to 6x plus 8, that's where on the right-hand side, and we want to find x, we want to go back to the left, then we want to just transpose to have x alone on the right-hand side. We have 6x plus 8, we want to get rid of the plus 8 first. It's adding. When I carry it across, we'll do the additive inverse, right? So remember that I'm trying to write it like how many teachers do it. So we write y is equal to 6x plus 8. We carry it across, we get y minus 8 is equal to 6x. So if we want x alone, 6 is multiplying on the right side. Let's get rid of it by carrying it across. And the opposite of multiply is multiplicative inverse, or easier to say, to divide. So it'll be y minus 8 all over 6 is equal to x. And now we can switch. Our input is not y, it's x. So we change the y to x, and our output is f inverse x. So f inverse x is equal to x minus 8 all over 6. And if we look at our pink function boxes, let's try that. If we start with x on the right-hand side, and we go to the left, instead of adding 8, the first thing we do would be minus 8. So it would be x minus 8. And we get our answer. What's the next step? We're going to the left. Instead of multiplying, we'll divide by 6. That's exactly what we wrote. So we've completed this part of the question. May 2011, number 6, part B. The diagram below shows the line segment which passes through the points A and B. So we have a straight line there. Determine, part 1, the coordinates of A and B. So if we look at A, and let's see, how do we write it? We write it in the order x and then y values. Right? Remember that is alphabetical order. X comes before y. So let's look at A and come down and hit the x-axis. What number is that? Minus 2. And if we hit A and we go across to hit the y-axis, it hits at 3. So A is minus 2, 3. And B, similarly, look at the x value of B first. So come down, hit the x-axis, or use a ruler to help you if you're getting problems. And x is 4, and the y value, when we go across to the left, will be 6. So we got the 2 sets of coordinates for both points. Part 2, the gradient of the line segment AB. Now, there are many ways to do this, but I found the easiest way for my students would be, let's say that the gradient is the change in y over the change in x. And we can write all sorts of formulas, y2 minus y1 over x2 minus x1, delta y over delta x, so on and so forth. Or, let's see, since we have a graph, let's just draw the lines. How do I go from A to B? From A, I can go across to the right. And how much am I moving to the right? I'm moving from minus 2 to 4. So you can count it. And you see you get 6 units. And then when we reach there, we go up. That will be the change in y. So the first one was change in x, which was 6. And now we're going upwards. So we're changing in the y direction. And we're going up 3 units. So we can rewrite m is equal to 3 over 6 from our diagram. And we could break that down, 3 into 3, 1, 3 into 6, 2. So m is equal to a half. So the gradient is a half. And for the last part of the question, part 3, the equation of the line which passes through A and B. So let's write the general formula for equation of a straight line. Y is equal to mx plus c. If we're using American text, then it'll be mx plus b. And what do we know? We know m. We worked that out. We worked out the gradient. It was a half. So it's a simple substitution. And c is our y-intercept, where it cuts the y-axis. And we could look at our graph and we see it cuts the y-axis at 4. As such, y is equal to a half x plus 4. And that's it. We've completed the question. May 2011, number 6b. The line L passes through the points S, which is at 6, 6, and T at 0, minus 2. So let's make a little sketch, even though they didn't give us one. for the x and y axis. You could do this freehand, that's fine. And s is 6, 6, so that's somewhere in the first quadrant up on your right. And t is 0, minus 2. The x value is 0, and the y value is minus 2. So that means it's cutting the axis at minus 2. Determine the gradient of the line segment L. So since we've done this freehand, that's okay. Let's do the same thing we did before. Gradient of a line M is equal to change in y over change in x. So let's draw a little arrow going across, and that will be your change in x, which works out to be 6, because we are moving from x is 0 to x is 6. And then our change in y, we're going upwards. We're moving from minus 2 to 6, so that means our value there that we're changing is 8. So m is equal to, let's substitute it, m is equal to 8 over 6. And we could break it down, 2 into 8, 4, 2 into 6, 3. So m is equal to 4 over 3. That's the gradient of the line. Part 2, the equation of the line. So if you want to find the equation, let's write the general formula of a straight line. Y is equal to mx plus c. And y is equal to 4/3 x, because we worked out the m already. 4/3 x, and from our sketch, we saw it was cutting the y-axis at minus 2, which is actually the point T. So y is equal to 4/3 x minus 2. And for part 3 now, the midpoint of the line segment TS. So if we want to find the middle of TS, then really what we want to find an x and a y value of that midpoint. And how do we find the middle of the x values? Well, we really want to find the average of those two values. And how do we find average? We add up the x value of s and the x value of t, and we divide by 2. And similarly, what we want to find for the y midpoint value, we want to find the y value at s and the y value at t, and add them up and divide by 2. So let's substitute. 0 plus 6 all over 2, those were x values, and our y values were minus 2 plus 6 all over 2. 0 plus 6 is 6, 2 into 6 is 3, so the midpoint of TS, the x value is 3, and minus 2 plus 6 is 4, 2 into 4 is 2, 3, 2. And pretty much, it might not be exact, but if you follow our sketch, you can see that it falls somewhere within there. You can do this, you can redo this question properly on a graph paper and see it for yourself. Part 4, the length of the line TS. Now if you want to find the length of a line, look at our sketch. What we're really asking us is to find the hypotenuse of this right angle triangle. And how do we find that? We're basically using Pythagoras' theorem. So Pythagoras' theorem talks about the fact that the square of the change in y, which is what we have here, and the change in x, when we square both sides and we add them up, that will give us the square of the TS, or the hypotenuse. So let's substitute. TS squared is equal to delta x squared plus delta y squared. Delta means change in. So change in x and change in y. And we could substitute the values. TS squared is equal to 6 squared plus 8 squared, which is 36 plus 64, which is 100. So TS would be, let's carry the square across, we'll get the square root of 100. As such, TS is equal to 10 units. That's the length of the line segment TS. May 2013, number 4b. The point A with coordinates -1, 4, and B with coordinates 3, 2 are the end points of a line segment AB. So let's make a sketch. Put up our x and y axes. This sketch will be freehand. And of course, where the intersect is 0. A at -1, 4, and B at 3, 2. We're just averaging to give us a general idea what it looks like. This way, students get a better grasp of the visual picture of what it actually is. So we're actually looking at AB because we're talking about a line segment. Determine, part 1, the gradient of AB. So if we're looking at the gradient of AB, what we do, easiest to start with the point on the left, which in this case is A, and move to the point on the right, which is B. So we're moving from A to B. First thing to do is move across horizontally and then vertically. So if we're starting at A and moving horizontally across with that purple line moving to the right, we're moving from -1 to 3. That means we're moving 4 to the right. So that will be the change in our x values, plus 4. And now when we've finished moving to the right, we go downwards. We go vertically downwards, so that means our change in the y values moves from 4 to 2, so it is minus 2 is the change. To calculate the gradient of AB, gradient is normally represented by the common letter m. So m, AB is equal to change in x over change in y over change in x. And that is equal to, from our sketch, minus 2, 4. So minus 2 over 4, we can cancel. 2 into 2, 1, 2 into 4, 2. So the gradient of AB is minus a half. Part 2, the coordinates of the midpoint AB. So what we want to do is find the exact middle of AB. Let's put up a little yellow arrow there to give us an idea where it is. It might not be exactly precise, but if we want to find the midpoint of AB, what we're actually doing, we're looking at the x coordinates first and then the y coordinates. We look at the two x coordinates, that of A and B, and we're actually finding the average or the middle. And how do we find the average of 2 points? We add them up and divide by 2. So that will be the midpoint of AB will be the x value of A plus the x value of B all over 2. And similarly, the y value of A plus the y value of B all over 2 will give us y value of the midpoint. And we can substitute. That's minus 1 plus 3 over 2 and 4 plus 2 over 2. And minus 1 plus 3, that's 2. 2 into 2, 1. So the midpoint of AB is 1. And if we look between minus 1 and 3, 1. And similarly, for the y value, 4 plus 2 is 6. 2 into 6, 3. And if we look at the y values, what's the middle of 2 and 4? 3. As such, we got the middle of AB as being 1, 3. Part 3. The equation of the perpendicular bisector of AB. It's a line which is running at 90 degrees to the line AB. AB we already have in green, so if you want to put a line running perpendicular to that, we'll represent that by the line in yellow, passing through the midpoint, because it's bisected. As such, if we want to find the equation of the line, we will need to find out two things. One, of course, is the gradient. So how do we consider gradients of two lines which are perpendicular? Well, the product of them will give us minus 1. So minus 1 is equal to the gradient of AB times the gradient of the perpendicular of AB, which is what one we have in green times one we have in yellow. And we know the gradient of AB, we worked that out in part 1. So we can substitute minus 1 is equal to minus a half times the gradient of the perpendicular AB, bisector AB. And if we want to find that yellow gradient, then we need to move the minus a half across. The 1 is on top. When it goes across, it will end up below. The minus 2 is below. When you carry it across, it will end up in the numerator on top. And we have a minus times a minus. Two same signs will give us an add. And 1, 2 is 2. So the perpendicular bisector, the yellow line, the gradient is 2. And let's see if this makes sense. The green line was going, when it was going to the right, it was going downwards, so it was negative. While the yellow line, when it's going to the right, it's going upwards, so it's positive. So that's why we got minus a half for the green line, and we got plus 2 for the yellow line in terms of gradients. Now, since we know that the gradient is change in y over change in x, then we can substitute. So the gradient of AB, the perpendicular line, is 2, and that is equal to, in order to solve for the general equation of the line, we can say change in y is y minus 3. And where we're getting 3 from? 3 is the y value of the midpoint over x minus 1, and 1 is the x value of the midpoint. Those things we worked out in part 2. So if you notice this now, we have 2 is equal to y minus 3 over x minus 1. Therefore, we can rearrange and make y the subject of the formula, and that will give us our equation of our line. So two things to remember. We're using the gradient of this yellow line, which is 2, and we're using at least 1 point which appears on the yellow line, which is the midpoint of AB. So if 2 is equal to y minus 3 over x minus 1, we can carry the x minus 1, which is in the denominator, across. It's dividing on the right-hand side, so when you carry it across, it will multiply. So we get 2 times x minus 1 is equal to y minus 3. And we can expand the brackets. 2 times x is 2x, 2 times minus 1 is minus 2 is equal to y minus 3. And if I want to find y alone, move the minus 3 from the right-hand side across. So that gives us 2x minus 2 plus 3 is equal to y. As such, y is equal to 2x plus 1. And that's the equation of the perpendicular bisector of AB. Couple things to note: the gradient is positive, plus 2, and it cuts at the point 1. May 2013, number 5b. Given that the function f of x is equal to 2x plus 1 over 3, and we can draw a flowchart diagram so students can see it differently. If the input is x, then the first step will be to multiply that x by 2. And now that we have 2x, the next step will be to add 1. So we have 2x plus 1. And now that we've gotten that whole thing, then we can divide by 3, and that will give us our output, which is f of x. And we have another function g of x, which is equal to 4x plus 5. That means that the input is x, that's a yellow box now. We're multiplying by 4 first, that will give us 4x, and we're adding 5. And that will be our output g of x. Now that we have these two functions, what do? We determine the values of part 1, f g of 2, that composite function, which means that two functions are operating, one after the other. So which function operates first? The function which appears on the x, or the value. So the value that we're dealing with, the x value we're dealing with, is 2. And what is closest to the 2? G. So if we want to find f g of 2, the first thing to do is work out g of 2. So let's write our formula, substitute and solve. So g of x is equal to 4x plus 5. And if we substitute now, g of 2, because x is 2, will give us 4 by 2 plus 5. And that is 8 plus 5, which is equal to 13. So we know g of 2 is 13. What do we do with this 13 now? Since we have f g of 2, and we worked out g of 2 as 13, then we could replace that part. That will give us f of 13, meaning we're operating with 13 as the input in the function f. So write the formula, f of x equal to 2x plus 1 all over 3. Substitute, f of 13 is 2 by 13 plus 1 over 3. 2 by 13 is 26 plus 1, 27, 27 over 3. So f of 13 is 3 into 27, 9. So the composite function f g of 2 is equal to 9. Now let's see if we put it into our flowchart, if that works. So if we put 2 into, we're operating with g first, 2 into the yellow input box, and we multiply by 4, 4 2s are 8, and we add 5, that will give us 13. So g of 2 is 13 if we're coming down in the flow diagram, and that's exactly what we got on the right hand side. Now if we take that 13, which is the output of g, and we now put it into the pink boxes as the input, then 13, and we multiply by 2, we're going to get 26, and we add 1, going to give us 27, and 27 divided by 3 will give us 9, which is our output. So we actually got that. We got f g of 2 is equal to 9. And for part 2, the last part of the question, find f inverse 3. So f inverse 3 means that the output of the pink boxes is 3. So what is the input? They actually want us to go backwards. So the first thing for us to do, write the function. There are two ways to do it. We can go back up the pink boxes. Let's see if we go back up. If the input is 3 and we are dividing by, and before that we are dividing by 3, if you're going backwards, we will multiply by 3. So 3 3s are 9. And then instead of adding 1, we'd subtract 1 because we're going in the opposite direction. So 9 take away 1 is 8, dividing by 2. We're going backwards. So 8 divided by 2 will give us 4. Let's see if we get that using the standard way the teachers normally teach. So if we write the function f of x equal to 2x plus 1 over 3, normally teachers suggest that you replace the f of x by y and the x on the right hand side remains the same and make that the subject of the formula. So y is equal to 2x plus 1 all over 3. So we want to carry the 3 across. The 3 is dividing on the right hand side. When you carry it across, it will multiply. So you get 3y is equal to 2x plus 1. And that means if we want to get the 2x alone on the right side, let's move the plus 1 across. It will subtract. So it means 3y minus 1 is equal to 2x. And if I want x alone, then 3y minus 1 all over 2. And as such, f inverse x is equal to 3x minus 1 over 2. Remember, when we reach this stage, we're converting the x into f inverse x, and we're converting the y into x. Now that we know that, we can solve for f inverse 3. We have our formula, so let's substitute. 3 3s are 9 minus 1 all over 2, and that will give us 8 over 2, which is 4. So the same thing we did on the flowchart, going backwards on the left-hand side, with the pink boxes going upwards. It's the same solution we got on the right-hand side. This brings us to the end of CSEC past paper questions in the topic of relation, functions, and graphs in section 1 of paper 2. This question also comes in section 2, but this video only dealt with those that came in section 1. This video looked at the past paper solutions from the years May 2009 until 2013 for those 5 years. Our next video will be looking at the next 5 years, which are from 2014 until 2018. Feel free to look at the description down below so you can follow all the order we suggest to cover the entire math syllabus and all the solutions.